Welcome to the Infrastructure Podcast. My name is Anthony Oliver, and in today's podcast, we are going to take a deep dive into embodied carbon and try to get a better understanding of why infrastructure professionals need to make its assessment more than just a nice add-on, but a fundamental part of the design process. While operational carbon, emissions from heating, cooling and electricity use has traditionally been the focus of sustainability efforts, embodied carbon, emissions that are effectively locked in at the point of construction and cannot be reduced over time, is now taking centre stage. To discuss this issue, my guest today is Adrian Campbell, founder of the Change Building Consultancy and someone that I like to describe as an industry sustainability guru and my go-to expert when it comes to reducing carbon across the infrastructure lifecycle. Full disclosure, I've known Adrian since we studied civil engineering together at the University of Southampton back in the 1980s. He did the studying, as I remember.
Nice.
Adrian has made a return to the University of Southampton as a tutor and a lecturer, and as Royal Academy of Engineering visiting professor in sustainable development and climate impact. He has just produced a new guide to help students get to grips with assessing embodied carbon, which should, I hope, provide the skills and judgment to help improve designs and help move us towards the goal of net zero carbon. For students entering the fields of architecture, engineering and construction, embracing this notion of embodied carbon assessment is no longer optional. It's, according to Adrian anyway, a vital skill for reshaping a sustainable built environment. As he puts it, having an awareness of the reasons for its adoption, the why, and some experience of assessment, the how, is now expected as part of the role of the engineer. So, let's find out a bit more about why students should engage with embodied carbon and this whole way of thinking really early in their careers. So, Adrian, welcome to the Infrastructure Podcast.
Many thanks. Great to be here. Yeah, it's interesting. We didn't learn any of this at university, did we?
Well, some would say I didn't learn a huge amount at all. Anyway, I digress. Let's get into embodied carbon. So tell us, why is embodied carbon assessment becoming such a crucial issue in the built environment?
Oh, that's simple. That's climate change. It's the game-changing issue, meaning engineers now have to think really critically about limits and understanding that pollution, emissions, waste, it all has to go somewhere. There is no way for this stuff.
But why embodied carbon? Because I mentioned operational carbon, which people are maybe more familiar with. Why is embodied carbon really important now? And what impact does it have on the overall carbon load, I suppose, that we're putting out there as an industry?
Well, we've got a legacy of really poor performing buildings that we have to do something about. It's why retrofit is really so critical. We might have to also move away from burning stuff for energy. That's bonkers, actually, in thermodynamic terms. But we need approaches to energy that recognise that. And as the late, I think, Max Fordham would have said, recognising the Sun-Earth system as the basis for energy provision and performance, and that we have to design with that in mind. But the critical bit about embodied carbon is for new build and major retrofit. And here, because fabric performance, building systems, energy sources, all of that has become much less carbon intensive over time, embodied carbon is now the dominant source of emissions over the building life. Right. So if we go back, back to early 90s, maybe that, one rough rule of thumb was maybe it was 10% of a building's impact. Maybe 10 or 15 years ago, it could have been about 50%. Now, with more energy efficient systems, it's probably the whole lot in net terms anyway. So it's the dominant source of emissions we have to deal with.
But measuring this is not always easy. I mean, you wrote on LinkedIn recently, I get there are some tricky bits to it, to getting assessments more accurate and comparable, etc. But I'm still amazed that some professionals seem to think embodied carbon assessment should only be done by specialists. Probably them. Why do you say that? I mean, is it currently being subcontracted out? Are we abdicating our responsibility for measuring all this trickiness?
Well, look, I'm not going to be getting any Christmas cards from them, am I? Right? Sorry about that. But and it's crazy. Like, I think over 3,500 people have had a look at that post, so it must have been saying something that resonated with them. If you need kind of numbers validation for those sorts of things. But look, there is a really important role for these consultants, but mainly in combining information from across a very broad supply chain into more comprehensive assessments. But my point, and I think I was trying to get across, is that if we want to get better early design decisions made on projects, that we have to balance a host of these different issues. That engineers need to be conversant with carbon and conversant themselves. There's no point looking over the table and saying, oh, sorry, Mr. Klein, I won't. Give me a bit of time, I'll do some design, and then I'll get to the carbon bit a bit later. And that person over there is going to do the numbers for us. Or is that a bit too harsh? I don't know. No. So look, we need to be conversant with this. And the only way to do that is by getting into those numbers yourself.
But the good news, I suppose, that you say that embodied carbon assessment is increasingly common in practice and is a rapidly developing area of both technology standards and regulation. So who is driving that change?
It was really nice, and one of the kind of comments on the LinkedIn post was from lovely Alice Moncaster, and she noted, like, well, we've come a really long way, haven't we, Adrian? And that's true, we have. Look, we were looking at what was then termed embodied energy back in the late 90s on buildings like the Gherkin. The trouble was we didn't have the data or the methodology to actually incorporate it meaningfully into the building assessment process. Now a lot of that's in place. So we've got data, we've got methodologies, and now we're just looking for a bit of willingness to actually embed this. But the really big change, I would say, is that it's being asked for by clients. So that's particularly now also in public procurement. So if you go north of the border up to Scotland, it's part of the net zero public sector building standard. It's now no longer a want to do something, you have to do this as part of your job.
Yeah. But I suppose on the one hand, it's great to know this when we're designing and building new stuff, but we're sitting here in the Royal Festival Hall in the South Bank in London, surrounded by vast amounts of concrete, which have got, I imagine, quite a lot of embedded carbon in there. So I suppose the assessment of these, where we are with embodied carbon, it enables us to know the value of a building when we may want to retrofit it or knock it down. Is that part of the process?
Well, it's not contradictory to love a bit of brutalism, right? But this stuff has been here, and hopefully it will be here for ages. The thing is about what do we do now moving forward with the work that we do, and we have to change the way that we think about building design and the materials that we use. What we don't want, what the guide was for students not to be fazed by what seems to be something apparently complex. And they needed to kind of get into the topic and be able to make judgments on projects to change the way that we do buildings into the future. And that's what we were trying to do, is get them comfortable with that decision-making process. So not to oversimplify, and it can get very complicated and even complex, but ultimately it's just summing up one number times by another number, and that's not beyond the wit of an engineer.
Yeah. Well, you mentioned the guide. You produced it specifically, I suppose, for your students at Southampton, but I imagine you want to get it out there to a wider cohort of students across the whole UK. I mean, how can such a short guide contribute to such a massively complex area?
Well, it allows future professional engineers, that's students, to actually start and get to know that this is part of their practice of engineering. So there's nothing kind of overly new about the guide. It collates lots of really fantastic information, which is now freely available to everybody. Yeah. It collates that, but it simplifies that, and it tries to take out some of this, the jargon that seems to kind of get in the way of doing things about it. So there are no plans currently open to offers to kind of make it into a more universal guide, but we've now transformed it from just an introduction to one part of the course into something that could be used across multiple modules in the whole degree course.
Yeah, because I noticed that you go through in the guide, and I'll put a link in the show notes. It is available. I imagine it's a free to download available.
Not yet.
Oh, right. So, okay.
Can be.
Okay, well, maybe I won't put a link in there. But, I mean, obviously, you've done it with the University of Southampton, and it does try to highlight which bits are relevant to which modules in their education courses, whether on architecture or engineering. You try to make sure that it's aimed at those particular modules.
So we've got this progression idea to take them through from right at the beginning of their course in year one to start using carbon as a metric, the same way that you used kilonewtons or kilograms or newtons in per millimeter squared. All of those things is just another metric, right? So we start off really easy with very simple systems doing just assessments on the products themselves, and we progress over the years to increasingly more sophisticated assessments, ultimately to whole life carbons at a building level.
So what's stopping students right now really embracing this kind of thinking? Is it just lack of education time, lack of course time, or is it just it's just missed out of the curriculum because no one's thinking about it? What's stopping it?
So nothing really. So it just takes an ability to change the way that we currently present modules and actually the tasks that they're asked to do on modules. So if you're designing a simple steel beam, you might come up to say that it's safe, it doesn't deflect too much, but it also might, and you might work out how much it weighs, but there's nothing stopping you also quantifying how much carbon there is in that material and the variations of carbon in materials
so it's not a fundamental shift. I mean, they're still going to be learning and have to learn these fundamental skills that you need to become an engineer, structural engineer or whatever. But what you're saying is there's a way of thinking. So you're actually bringing a wider set of tools into your work.
Things have still got to perform. They've still got to do a job. Just now, you've also got to do another job, which is help us to get towards net zero carbon.
Presumably, though, and what you're trying to do at Southampton is to give the students that leave with their degree from Southampton a competitive edge. Will this do that? Will this give them a competitive edge when they come to getting a job?
Well, I'd hope to think my students are. I've got that. Selfishly, that's how we introduce it to them. I could bang on about the climate emergency, but that's not going to motivate them, I don't think necessarily.
Really?
Yeah, really. It's quite odd that, they're not all little Greta Thunbergs.
Oh, right. Now, I've heard you mention this before, that you are very passionate about the way that engineers embrace their knowledge of carbon, but you've had slight concerns that students perhaps haven't been there quite at the same level. Yeah,
look, I've been on a real journey in terms of my understanding of sustainability and now the more specific focus on decarbonisation. I'm more of what we might call a construction ecologist. Right. I like to see how we might transform construction to be more in line with natural systems. That's where I want to kind of take my work and my understanding. My work is enormously impacted by seeing how development is done globally, not just in the UK, but globally, and some of the decision-making that is done there, or bad decision-making. So that's where I started off. It just so happened that, aligned to that has been this increasing recognition of the potential impacts that climate's going to have and what we have to now do about it. Well,
let's drill in a bit more about you and your career at this point, because you formed Change Building 8 years ago after a 20-year career at Arup. Why do you do that? What drives your passion for sustainable design?
Well, I actually bought the domain name for Change Building nearly 20 years ago. So I really liked my time at Arup. I still do work with them. I've got loads of mates there. But the way I think is, what Tim Harford, the economist, might call slow motion multitasking.
Right.
That I do lots of different things in lots of different areas, and somehow they seem to coalesce around a common idea about impacting and climate change. So that's what I did. But that just became increasingly harder for me to do in an increasingly large corporate consultancy.
Right, yeah.
So it's all, so that variation of roles and variation of emphasis was not something that fits easily into a corporate consultancy.
Well, you worked on many groundbreaking projects, pioneering the use of structural timber and pushing boundaries. I mean, give us some highlights. What would you say in your time as an engineer working out you're particularly proud of that's really moved the bar in terms of our thinking and our use of sustainable construction techniques?
I've been really lucky to have worked on some amazing projects globally with fantastic architects, very forward-thinking clients. So whether it's the Gherkin Low to No in Helsinki, recently more on mass timber systems, but every single project I've ever done, I've thought as an opportunity to innovate around sustainability and do something a little bit different. It doesn't matter how small or big that's been. Some have been bigger than others. And so that's great. Workstack in Greenwich recently is a bit of a standout for me, not just because it's new, won lots of awards, fantastic, but because we had to be really determined to keep to the original idea of building a light industrial unit in mass timber.
Yeah.
With all of the changes in fire regulations after Grenfell, battling through COVID, costs of timber inflating, all those things. It was an enormous challenge. And what was really nice, we had enormous pieces of wood over 19 meters long. So it was a bit of fun as well.
So what has all that taught you about delivering sustainable designs? Is it actually, in your experience, easier than it seems? Or is it just blooming hard work?
Well, yeah, some of it's really hard work. But the thing I would say is you have to have a really strong concept. You've got to know what you're trying to achieve, and you've got to stick to your guns. Yeah. It would have been so easy to fold really early on projects and just say, oh, that's a bit too hard. We'll do it how we normally do it then. And that's not going to get us where we want to go.
Right. You've also travelled and spent a few years running the Cape Town office for Arup. Would you say that travel and I suppose in getting that experience from around the world is a critical part of your development and the critical part of any engineer's development?
Well, I loved working abroad, and we've also had the idea that maybe there's time for one last hurrah. I don't know. It certainly
gives... Are you off somewhere, are you?
Well, who knows? Open to offers. It certainly gives you a different understanding of what you can and should be done. So look, if you're, let's say, in Cape Town, interest rates were 12%, not 2 or 3%. And so people needed to get stuff done really, really quickly. So no surprising, you had a different approach to doing things differently there.
Yeah. What's the Positive Collective that you formed in 2020? What's that all about?
Well, that's me, Flo and Patrick looking at housing and regenerative system design. So we formed that as part of the work we did on the Home of 2030 competition into housing. We were one of the shortlisted finalists, which was great. Unfortunately, didn't win it or get to build it. Thanks, Michael Gove, for not funding that, But hey, what we continue to look at areas of innovation around very progressive building design, and what do we do around major challenges like the housing crisis?
Well, we heard last week about the role of retrofit in tackling the housing crisis, the week before about the way that Legal & General is tackling the affordable housing crisis. So it is a big issue. So you're still on that, are you?
Yeah. One of the things, back to slow motion multitasking.
Well, alongside your passions for sustainable design, I know that you are also a very passionate cyclist, Adrian.
As are you.
Well, I've done a bit. I've done a bit.
As are you.
Anyway, I presume you've parked up for the winter, have you? What have you got planned for 2025?
Right. So my mate Andy and I, we're back up to Bonnie, Scotland, to cycle from Inverness to Glasgow. Right, bike packing for about 4 days in June.
Oh, right.
Should be fun.
Yeah, well, watch out. There are hills in Scotland.
Yeah, there's a big lump in the middle.
Yeah, I'm just warning you, there are hills.
There's a big lump in the middle, which we're not looking forward to. That's why I'm out training again.
Good stuff. Well, look, before you go there, we need to get this whole kind of embodied carbon issue nailed. So let's talk about challenges to industry adoption. What would you say? You're coming out. You obviously you're trying to persuade students that it's something that they should embrace, but they'll get into industry. So what would you say is the biggest barriers in industry to widespread adoption of embodied carbon assessment?
I have a very simple way of that. I look at this. I have to understand what I have to do and what I want to do. So clients really appreciate understanding what their responsibilities and regulations might be in terms of addressing it. And they also like to look at the opportunities. And this is the negotiation in design. So it's the skill of the design team is actually demonstrating the value of new options to clients and what those will bring.
Yeah. You talk a lot about the concept of life cycle assessment, and you say to get consistency and completeness in the processes of evaluation. And that must be a hard thing for clients who don't necessarily, quite often, they don't necessarily want to look too far down the track in terms of what their responsibilities are. They want to focus on how much it's costing them right now. Is it a tricky thing for designers to get that life cycle assessment across?
Not really. It will really depend who is doing it and when they're doing it. Look, I've worked with some contractors, and one of the best things was, a guy designing a piling map, and he's coming up to me and saying, "Adrian, can you help me with this? I found this tool, the iStructC tool, and I've used it to try to decide what a more appropriate piling mat design would be." And he was fantastic, Stevie. And he was an older guy, never come across this before, interested what he can do in terms of helping, include this in his work. And he's taken the effort to go and find out how to do it. Right. There will be challenges along the way in terms of what is most cost effective and what's most appropriate. But regulation and finance is changing here. So especially with the use of timber, we've got new emerging European regulation certification about carbon storage. So suddenly we will change the costing and the business case around carbon away from traditional methods.
Yeah, which is in many ways what you're trying to get across in the guide, because you're talking about practical applications and highlighting that embodied carbon assessments can actually be used to inform design and improve design. Where are the big wins for you then? Because you talked about the guy with the piling mat, but where are the big wins when it comes to actually the design process?
I know quantities of things are really important, so the measurement of the total amounts of carbon are really important, but I think we have to think much more critically about quality. So get back to this idea of ecological consistency and changing the selection of materials overall. So I spend an awful lot of time looking at biogenic or bio-based materials as an alternative to conventional materials. So there's an awful lot, I think, we can do in just changing what we think is an acceptable material to use, full stop.
But a lot of that, I was at a conference this week when they were talking about the use of biogenic binders as road surfacing materials and removing petrochemicals from road surfacing. And it's fantastic. It's all incredibly doable, but because it's not done very much, it comes currently at a cost. So how do you get over the fact that in order to make it lower cost, you've got to get more people doing it?
So engineers can do their numbers, they could do their sums better.
Right.
Let's be more efficient. We could also think around the kind of concepts of sufficiency. So what actually is enough to build? I know we're all completely crazy growth fetishing at the moment. Everybody wants to do more, but we have to do that in a realistic and rational way within limits. So engineers and clients have to now understand limits, not just linear growth methods.
But is that a cultural thing more that you've got to overcome rather than a technical thing then? Because, is that culture of doing it just the way we always do it the thing you really need to tackle?
Yeah, I don't understand why people are so reticent about looking at different ways of doing things. Maybe there is just this idea that, well, I did it yesterday. I don't really want to have to try very hard. Let me just do it the same way again. Yeah. That's not what I've never, ever been interested in that as a way. My God, life would be far too boring and short for that.
Yeah. But you also say that minimizing material use, key to reducing carbon, requires a good understanding of efficient overall design of buildings and the elements within them. I mean, the problem is, I suppose, that students typically don't have that rounded experience. So how do you get over that?
That's going to come, right? Everybody's on that journey. They'll develop up their own ideas and their own feel for things. But every single hierarchy I've ever come across, whether that is carbon or waste or energy, starts with an idea of reducing consumption overall. So let's just do our job a bit better. About employing traditional ideas of efficiency, more effectively on projects. So we can start there. I think what Will Arnold is like to call use less stuff. He says it all the time, doesn't he?
But we've got a multitude of tools and digital tools that we can use to measure stuff and to monitor stuff and to actually kind of keep track of it. Is it simply a case of using that, or how do students actually tackle this balance between the sustainable goals and the real world constraints of cost and material availability?
Well, look, the embodied carbon assessment, which wasn't a million miles from the final numbers, I did on one sheet of paper in my notebook by hand using accurate material quantities from the BIM model.
Right.
Fantastic. And I selected the embodied carbon factors from the data on the actual materials that were going to be used on site. One piece of paper by hand using a calculator. It doesn't need fancy tools to do a simple one number times by another number.
Careful, right? You're going to a difficult area there. Goodness me, you're destroying the whole industry.
So, the iStruct have done an amazing job about actually making some of these tools free to use. So I've got third year architectural students using the iStruct carbon tool to justify their selection of materials on projects in year 3 of an undergraduate course.
Yeah. So I suppose just to draw this discussion to a close, I think the big challenge right now is getting professionals, but also the next generation of professionals, your students, really excited about this whole concept. What do you see as the biggest innovations or changes in embodied carbon reduction that students should be getting excited about right now?
Well, we've got a lot to think about the differences between extractive materials, metals and minerals, and when those impacts happen, and bio-based materials, which grow and might emit their pulse of carbon at the end of life. So we have an incompatibility at the moment between how do we measure upfront impacts against potential impacts later on in life and dealing with that. We've also got issues about how do we embed principles of the circular economy more effectively into life cycle assessment. So we'll have more to think about on how to do those. But, we're not accountants. Engineers are not accountants.
No.
It's not about just doing sums for the sake of doing sums. It's about doing them.
It's about inspiring
to
them.
actually say, look, this is the sort of impact I can make in my professional career through better design and using carbon as a way to change the way that we actually build buildings.
So you've got your guidance. How do you see it evolving then? Is it going to be a set text for infrastructure students? Is it a step on a journey?
It started off just as a guide for the first year students. It's now then into second years, third years, and now the fourth years. We're doing an advanced structures course, which uses this as well. So it's growing. There's been many people on LinkedIn that have come back and said, where do I get a copy of this guide, Adrian? And I've gone, have to check the grammar, as you all know, Anthony, before I issue it out. But it links to many great guides out, so that actually you don't really need the guide to get into this.
Right. So if someone wants to come and help you do that, then I'm sure you're very, very, very open.
I'm absolutely delighted to help with that.
Finally, though, you remind students that design is complicated, a complicated set of trade-offs, and you add, it is important to maintain this view on overall design value of options, not just blindly chase reduced carbon targets. What do you mean by that then?
Well, look, poor students, right? They've been inundated for 18 years with this idea that, there's one answer to a simple closed problem. And if they answer that correctly, they'll get more marks.
Yeah.
They arrive at university with no idea of the complexity of decision-making on multiple facets that they have to face on projects in the real world. All we want to do is get students comfortable with trying to make better decisions, and that they understand that there is no one perfect solution out there. They need to get the skill to make those judgments.
Yeah. Well, it's a great point to end on, Adrian. I think, getting students really excited about this is a fantastic goal, and certainly the work you're doing there seems to be hitting that. It's a great point to end on, because we're just about to be overrun, I think, by people coming into the Royal Festival Hall here. So thanks so much for taking time out of your busy day for talking us through this guide, and for really sharing your thoughts about why embodied carbon is going to be such a big, embodied carbon is going to be such a big issue. Exactly. Thanks for joining me on the Infrastructure Podcast today.
Thanks, and it's been great.
Good stuff. Well, look, that's all we've got time for on the podcast today. But there is more in the pipeline as we continue to probe the big issues faced across the sector. If you haven't done so already, do check out the Infrastructure Podcast website. That's www.infrastructure-podcast.com, where you'll find background information and all the latest podcasts to listen to and share. Thanks for joining us today, and thanks again to Adrian. Maybe we'll get a link to his report on the show notes at some point. Who knows? One day. Thanks again to Adrian, and I look forward to seeing you again very soon.